So the directrix is in the lower section. We will have a hyperbola that looks perhaps like this. Okay, we'll later on find out what the intercepts are, but to begin with, this is the rough sketch. So since it's a horizontal asymptote, it's a horizontal directrix, and it's negative, so the equation is that we'll be using for r is equal to ed over 1 minus e sine theta, right? So e in this case is 6, so I'll plug in 6. Now the equation of this line is y is equal to negative 7, so the d is going to be 7, so because it's the distance, so d is 7, so we'll use the 7 here, and 1 minus 6 times sine of theta. If I simplify that, it's going to be 6, 6, 36, and 42, 1 minus 6 sine theta. Alright, 1 minus 6 sine theta. However, there is a limitation. In this case, of course, it doesn't apply. The denominator should not become 0. Right, that's one of the limitation there. So now that you have r is equal to 42 over 1 minus 6 sine theta, this is the equation in the polar form. We need to get at least one definitive point. So what we'll do is, let me use a different color. We'll put plug in theta is equal to 0, right? Theta is equal to 0. That would make it 42 over 1 minus 6. Sine 0 is 0. So therefore this becomes, the entire thing is going to vanish. So this is going to be 42. So therefore when theta is 0, the r value is going to be 42. So that means it's going to be somewhere here, which is theta is 0 and r is going to be 42. So therefore how do you write that? You write that as 42 comma 0. That's how you write it in the r theta format. So 42 comma 0 degrees. So that's going to be your x-intercept up there. Now we'll talk about another angle. So we'll take theta is equal to, say, 3 pi by 2. The reason I took 3 pi by 2 is because of this line here, which is 270 degrees. If theta is equal to 3 pi by 2, it would be 42 over 1 minus 6 sine of 270. Alright, sine of 270 is going to be like 1, a negative 1, so making this 6 plus 1, so that is 42. Let me put that in the calculator because it's almost night. I don't want to think. 42 divided by 1 minus, I should put that in the parentheses, 1 minus 6 sine of 270, close parentheses. Yes, it is 6. So therefore this value here is gonna be 6, in the sense negative 6, right? Because that's the r value here, so it's gonna be negative 6 over here. Okay, theta is 6. So we'll probably get this as one of them. And then what else do we do? We'll have to look at the other values if possible. So I don't know if I should look for another value for this or this much is good enough. Let me check the possibility if there's made any mistakes. 42 1 minus 6 sine theta. Okay, that looks good. And so it's about at 6. So if you are one of those graphs, right, with all the circle, the r theta curve, so the radius here, this circle that you're going to pick is the 6th. So that's going to be this point here, and at the same distance, whatever the distance here, you will mark it here. So this will be negative 8 and 270 degrees. So that's how you will graph this number 14. Okay, I hope that helps. Now let's move on to the next number. I think the next one is 15, right? So in 15, what does it say? E is equal to 1 and directrix is dr. Okay, spelling is bad. X is equal to negative 1.5. Right, directrix is negative 1.5. Alright, since E is equal to 1, we know it's a parabola. Okay, so r theta curve, negative 1.5 somewhere here. Okay, that's your x is equal to negative 1.5. I'm assuming it's going to be somewhere like this, but we don't know where the points are. Since this is a negative and it's a parabola, the equation is going to be r is equal to ed over 1 minus e cos of theta, right? 1 minus e. So plugging in the values, e value is 1 times 1.5, absolute value of that, and 1 minus e is 1 cos of theta. Please remember the limitation is 1 minus cos theta cannot be 0, or in other words cos theta cannot be 1. That's one of the limitations in this case. So we're not going to worry, because if cos theta is 1, this is going to be infinite. So our curve is going to be, this is going to be the infinite value there. So that's the limitation there. So it's not never going to go there. It's the, or in other words, it's going to be infinite then. So now what about the other? This is the equation, okay? This one is 1.5 over 1 minus cos theta is the equation. Now remember, we have to get 1 or 2 points to mark the things correctly. So what if theta is, say, 60 degrees? Or no, yeah, pi by 3. Let's put it pi by 3. So somewhere here, theta is pi by 3 is going to be somewhere here. Now if theta is pi by 3, it would be 1.5 over 1 minus cos of pi by 3. So cos 60, so I'm just going to put that in the calculator, I'm not breaking my head over it, divided by parentheses 1 minus cos of 60 close parentheses, that's going to be 3. So therefore this is going to be 3. Here the value is going to be 3 comma pi by 3. So when you graph this like that, how do I put it? Let's you get it, right? So here wherever the curve is, this point is going to be 3 comma pi by 3, r theta here. All right, now what about if theta is 180? If it is pi, okay, that is over here. If this is 180, right, this line is 180 or pi. So if theta is 180, it's 1.5 over 1 minus cos of 180. So cos of 180 is going to be negative 1. So therefore that becomes 1.5 over negative, is it negative 1? No, positive 2. So let me put that 1.5 divided by 2. So that's going to be 0.75. So in other words, this point here, the vertex, approximately the vertex point is going to be 0.75 comma pi, right? This is going to be 0.75 pi. So that is how, that's good enough. I think that is good enough. We have 2 points there. Okay, so to show this, we can also do pi to get a third point. So we have something like this. This is your 3 comma pi by 3, and this is 0.7.5 comma. Now why don't we put pi by 2 in this? So I'm going to use the same equation in my calculator. So clear, I'll go back up there, drop that equation, and just change the angle to 90 degrees, close parentheses, close parentheses. It's going to be 1.5. So this point is going to be 1.5 comma pi by 2. That's going to be your point there. The same applies on this side. It's going to be negative 1.5 comma, since it's 270, it is 3 pi by 2 over here. That's the opposite point. So here is how you would graph this curve, which is number 15. I hope that helps. Let's move on to the next one. After 15 is our 16. Is it 16? Yeah. So 16 problem says E is given as, I should probably use white. E is equal to 0.8. Okay. Vertices, I had to look up these formulas. I totally forgot about these formulas. Vertices are at negative 36 comma 0, and the other vertex is 4 comma 0. Okay, 4 comma 0. So that means look at the value of E, 0.8, which makes it a ellipse. So we know we are dealing with the ellipse here. So, and whose one point is at negative 36 0, that's one vertex, and the other one is at 4 comma 0. You will need a couple of other formulas also for this. Anyway, you should probably memorize it or write it down somewhere. So the first thing that comes to my mind is, hey, why don't we find the center, right? Why don't we find the center? And also the directrix, it has two directrix, one on the right and one on the left. I'm concentrating on the one on the right, so let's keep it x is equal to some constant, or x is equal to d value there. And what about the formula? So since we have a positive d here, so I'm going to use the formula ed by 1 plus e cos of theta. Yes, 1 plus e cos of theta. So that looks good. What did I miss? Okay, now what can I find? Now I can find a value, because what is a? A is nothing but this complete distance. So the midpoint here, if I add and subtract them, total distance is 40, so mid between 20, so this is going to be negative 16, 0. The center is going to be negative 16, 0, and a is equal to 20. That is one thing I can find out. So center is negative 16, 0. Let's write that down. A is equal to 20. We're going to use all of these things. What else do we know about an ellipse? We don't need the minor axis. How about the focus? Okay, so in order to find the focus, we can use the eccentricity. We probably know that E is equal to C by A. What can we find from that? We can find C, which is the focus distance. Yes, perfect. So let's do that. So E times A is going to be C, right? E times A is going to be C, right? That should make sense. E times A should make it C. What is A? 20. So let's multiply. Okay. So 0.8 times 20 is 16. So therefore C is equal to 16. That means it's 16 units away from here. So that means the focus has to be at the center. Normally it's at the center. I think there is a theorem associated with it, but I'm not sure. So the focus is at center. Very well. So that's your point. Now do remember there is another formula that we will need here, which is if this distance is given, right, you can actually find out how far the directrix is. What does that mean? So the formula from the center to directrix is given as A by E. So please do remember this. The center to directrix is always going to be a ratio of A by E. Did we find A? Yes, we did. Do we have E? Yes, we do. So it's 20 by E, which is 0.8. So 20 divided by 0.8 is 25. So therefore, the center of the ellipse, to the directrix. So where is the center? The center is here. From here, I have to go 25 units to this part. So that means 20 units is going to be to the vertex. From 20, I go further 5 units. So 4 plus 5 is 9. So x is equal to 9 is going to be, my directrix there. Okay, this is my directrix. Okay, that looks good. X is equal to 9. So do we have E? Yes, we do. We have D? Yes, we do. So we are good with the equation. So let's quickly write the equation. The equation of this ellipse is going to be ED, E.8D, which is 9, 0.8 times 9, divided by, what's it going to be, divided by 1 plus 0.8 cos theta. I have to multiply that. 9 times 0.8 is 7.2. So that's 7.2 over 1 plus 0.8 cos theta. Now that's your R. That's your R. For which problem is this? I forgot which problem. 16. Now remember, we need some points here, the lattice rectum points. We do need that. So please plug in theta is equal to pi by 2 into this equation, and also plug in theta is equal to 3 pi by 2 into the very same equation. We already have the other two vertices, and that's it. We can just graph this ellipse there. So hope that helps. That's 16. What else did you want? 17. E is given as 1.5 and the vertices are given as -3, 0 and -1.5. Is it 1.10? No, -15, sorry, my bad. -15 comma 0. So 1.5 is definitely greater than 1. So therefore we're dealing with the hyperbola there, right? So it's a hyperbola whose vertices are both here, okay, somewhere very far off. -15, 0, and the other one is going to be at -3, 0. So I'm thinking it's going to look like this, and it's going to look like this, with the center point here. So what's the center point for these two? The center point probably is going to be 9. It's going to be 9, yeah, -9, -9, 0, right? Isn't it -9? So 6 units and 6 units, yeah. So that's going to be the center axis. So let's write that x is equal to -9, okay? That's x is equal to -9. So again, this is a negative line there. So r is equal to ed over 1 minus e cos theta. Do we know e? Yes. Do we know d? Yes. So let's plug that in. So 1.5 times 9, right? 1.5 times 9 divided by 1 minus 1.5 cos of theta. That is 1.5 times 9 is 13.5 over 1 minus 1.5 cos theta. Now this is your r. Make sure you plug in r is equal to, we have r is equal to 0 value, right? R is equal to 0 will get you this part.